Assalamualaikum warahmatullahi wabarakatuh. My name is Hamzah bin Hamizan and my partner Nabihah Binti Khiruddin. We are from N38206A and today we are going to present the global and Malaysia adoption of precision agriculture technologies. First, what is precision agriculture? Actually, precision agriculture is a system approach for site-specific management of crop production system where we use the geospatial data techniques to manage each crop production inputs such as fertilizer, herbicide, seed, and many more. Then, what is the advantage when we use the precision agriculture? First, as for environmental, we able to reduce the input usage and also reduce the impact to the environment because most of the input is chemical. Second, as for economic, it helps to reduce the input cost and also labor cost. Since we able to manage the input, we also able to increase the yield productivity and gain more income at low cost. Now we move to global and Malaysia adoption of precision agriculture technologies. The first technology is variable rate technology. This technology focuses on application input with a different rate automatically across the field. There are two types of VRT which are map-based and sensor-based. Map-based system using the prescription map, while the sensor-based use the sensor to adjust the application rate. By using VRT, we can promote a uniform growth and this will increase the yield as well. The first adoption of VRT is in Seberang Perak, which focus on nitrogen fertilizer application. It also compares between the VRT applicator and the conventional method. Based on the comparison, the VRT is more efficient because it has a huge capacity of fertilizer which help to cover more area in 1 hour as compared to conventional method. Besides, this is the comparison of fertilizer application between VRT and conventional method for 3 seasons. Based on the result, we can see the fertilizer rate for VRT decreasing every season while the conventional method remains the same. This shows that VRT can reduce the fertilizer application. The second adoption of VRT is in Kedah, which focus on seeding application on different field level. The soil profile was determined by using automated land leveling system mounted on a tractor during the final stage of tilling. The data then being used to identify the leveling index and the variable rate seeding for each field. The field level was divided into 3 parts, which are high, low, and even. For VRT seeding, an additional 10% seeding rate will be added for high and low level field. Based on the result in graph, there is no significant difference of plant population in VRT, but it is opposite for conventional method. This shows that VRT help to promote uniform crop growth. The third adoption of VRT is in Georgia, USA, which focus on nematicide application. 2 types of nematicide with 2 different rates being used to determine the response of nematodes. The Termate 15G will use 0.51 kg and 1 kg per hectare, while the 1,3-D nematicide will use 33.1 kg and 66.2 kg per hectare. The result shows that 1,3-D nematicide is more effective than the Termate 15G in high nematodes population. However, the effectiveness of both nematicide is equal in low nematodes population. Therefore, it will be better to use Termate 15G in low nematodes population since it requires less amount of nematicide. This shows that VRT can influence the good decision making on the nematicide application. Next, the second precision agriculture technology is farm automation or robots. This technology uses machine, sensor, computer system, electronics, and data management to automate the crop production cycle. This technology also will increase the efficiency while reduce the dependency on labor. The first adoption of farm automation is citrus picking robot in Valencia, Spain. This robot was mounted on a tractor and using camera and electrical motor which extended using pneumatic for harvesting process. This robot needs 2 to 3 seconds to harvest 1 orange with 80% accuracy and also have 50% picking rates. The second adoption of farm automation is the laser weeding robot in New Mexico. This robot able to move itself and differentiate between weeds and crops by using GPS, camera, laser technology, and artificial intelligence. This robot can move 5 miles per hour and able to cover 15 to 20 acres in a day. This robot can kill 100,000 of weeds per hour by using laser. The third adoption of farm automation is vineyard spraying robot in France. By using GPS and self-driving technology, the robots able to move 4 km per hour for spraying activity. This spraying robot is suitable in steep vineyard since it able to keep it balanced even the slope is 45 degrees.
How we continue with precision irrigation. Precision irrigation is an irrigation scheduling system that is utilized to improve the root development process and reduce the overall wastage of water, nutrients and chemicals. The purpose of this process is to maximize the overall input utilization in the agricultural space. It allows the application of water and nutrients to the plant at the right time and place and in a small measured doses in order to provide it with optimal growing conditions. Let's proceed with advantage. Precision irrigation enables farmers to increase profitability by achieving higher yields per hectare and better quality crops while using less water, fertilizer and energy. Besides, they can enjoy greater predictability and stability in an uncertain climate. Next, it takes care of the plant's development needs by allowing the application of water and nutrients without waste at the right times, in the right place and in the right quantity. Then, it saves water. Using precision irrigation can cut down water consumption in farmlands by nearly 25%. It also labor saving. Apart from saving water, this method also cuts down consumption of energy, labor and money, thereby leading to large-scale savings in the long run. Precision irrigation also maximizing yields. This method leads to an average increase of yields by at least 8%. This leads to greater profits for farmers. There are few types of irrigation. There are surface irrigation, sprinkler irrigation, drip irrigation, and subsurface irrigation. This is climate-robust irrigation water management for potato production in southern Alberta. And this is drip irrigation on rock melon farm in Hulu Langat. Next, we proceed with weather forecasting. Weather forecasting is the application of current technology and science to predict the state of atmosphere for a future time and a given location. The foundation for models are mathematical equations based on physics that categorize how the air moves and heat and moisture are exchanged in the atmosphere. Weather observation can be obtained from ground sensors and weather satellites are fed into these equations. The observations are brought into the models in a process known as data assimilation. Some crops require certain high or low temperature to start their germination and continue further development. On the other hand, temperatures in combination with humidity are often used to predict various insect pests and disease occurrence. Based on this information, farmers can plan time for sowing, protection, harvesting, and other field activities in order to avoid negative weather effects and yield losses. Weather monitoring offers a set of measurement options to provide useful information about soil and crop condition, some of which are air and soil, temperature, relative humidity, soil moisture, rainfall, wind speed or direction, and evapotranspiration. As for the advantage, the sensor allows farmers to make better decisions about pesticide, watering and preventing disease. Farmers are able to better see and forecast upcoming rainfall, humidity, temperature and freezes. This can help them better prepare for their crops for weather conditions like frost, drought or heavy rainfall. It also saves costs and water resources. Smart farming leads to lower cost of labor, water and nutrients for crops. Besides, knowing the exact rainfall for each crop can help optimize watering, thus preventing overwatering, which can impact not only crop health but also the environment. Next is save time and be more organized. Being able to view water levels and weather conditions remotely save the time it takes to physically go out to the field. In addition, by knowing weather patterns, you are able to be better plan out what needs done during the day while avoiding rain or other weather. Furthermore, it's easier to make decisions. Everything from pesticide, seeding, irrigation and labor can be done more accurately with precise data. We can be better predict spraying times by tracking historical weather for the exact area and better anticipate disease risks through weather patterns and conditions. Besides, it is more efficient cross monitoring with less human error. Automatic monitoring will lead to more accurate data in less time and with less labor. These are the examples of adaptation weather monitoring in Northern California in grape farm and Southern Michigan in corn farm. An agricultural drone is an unmanned aerial vehicle used in agriculture operations, mostly in yield optimization and in monitoring crops growth and crop production. Drones have a wide range of uses in agriculture. However, their main uses are in acquiring highly detailed data through the use of different sensors. This data can be turned into different types of maps and 3D models of the area. These maps can then be used to analyze crop health, detect disease and stress in plants, and identify irrigation problems. As the advantage, drone is a fast data acquisition for accurate farm analysis. It is through a method called drone photogrammetry. It can help farmers and agronomists create highly accurate maps and 3D models of the area. With drone mapping software such as Pix4D Fields or Drone Deploy, image captured by drone can be stitched together to get a topographical map of the farmland. Drones can be fitted with different types of cameras like RGB, multispectral, and thermal cameras that will allow farmers to gain access to different forms of data. Next, it improves crop yields. Drones allow farmers to obtain crop data fast and frequently. This keeps them on top of things like irrigation issues, plant disease, and soil condition. Through precision agriculture, farmers and agronomists can improve overall crop yield by data-driven variable rate prescription. By using remote sensing technology, farmers will easily be able to identify areas of the field that are not producing healthy crops, find out what the problem is, and only target that area for any treatment that may be required. Furthermore, it also provides safer ways to spray crops. Pests and plant disease are always going to be an issue for farmers. Spraying chemicals manually will always pose a health hazard and is very time-consuming and labor-intensive. Using drones to treat infected plants is much safer and more efficient than manual labor and using land-based machinery. Smart drones also come with autonomous flight modes. This will allow farmers to plan flight paths only around areas that need to be treated and leave the healthy parts of field free from unnecessary chemicals. In addition, it helps fight climate change by reducing the use of chemicals through data-driven target treatment and reducing the needs of fossil fuel as drones are powered by intelligent batteries. Drones can help reduce pollution, help the environment, and help in the fight against climate change. This is the adoption of drone in Genting Tanah Merah Estate, Johor. Image collected from drones flying up to 400 meters above Genting's oil palms help the company spot fires in remote and inaccessible areas. The use of such tools mean image spanning 10,000 hectares can be reviewed by a computer in 4 hours compared to conventional method which take 14 days or more than that, and it took 20 people ordinarily to be done. This is adoption of drone in Kampung Paya, Nendam, Kedah. They began offering farmers the service of spraying pesticide on their paddy fields by using drones. They have standardized flying height, which is 1.5 meter, and speed 5 meter per second, that provides effective delivery of pesticide at the lower lip as well as uniform distribution. This also registered an insecticidal efficacy of 92 to 74% of 3 to 10 days after spraying insecticide. To conclude all above, it is proven that precision agriculture improves a lot in human daily life, especially in agriculture as it requires a huge area of planting. It is true that all adoption precision agriculture above shows a positive improvement in their farming activities, such as make better decisions on pesticide use and watering rates, save costs, water resources, time, and be more organized. Therefore, farmers are required to change to precision agriculture because it will help improve their farming efficiency and increase yield. We need more experts in technologies, especially in Malaysia, to adopt more precision agriculture, so that we can compete with other countries as well as reduce the imports of raw materials, especially vegetables of our country. So that's all from us. Thank you.